The findings revealed that disaster logistics during flood events face persistent challenges, particularly limited physical access due to submerged or damaged roads, unpredictable weather conditions, manpower shortages, and constraints on assets and coordination. APM highlighted difficulties in reaching scattered inland villages when main routes are cut off, while PDRM emphasized shortages of personnel in wide affected areas requiring interagency cooperation. Bomba, despite having land, water, and air assets, also faces manpower fatigue and logistical strain during prolonged operations. These challenges are compounded by the limitations of traditional delivery methods such as boats, trucks, and helicopters, which are costly, weather-dependent, manpower-intensive, and often unsuitable for narrow or high-risk areas. In terms of awareness and adoption of drone technology, the findings show clear variation across agencies. APM uses drones mainly for basic monitoring and light supply delivery but is constrained by short battery life, limited payload capacity, regulatory approval requirements, and a lack of trained operators. PDRM's drone usage is limited at the state level due to strict regulations, security concerns, and no-fly zones. Although drones are recognized as valuable tools for early monitoring and victim detection. In contrast, Bomba demonstrates the highest level of acceptance and integration. Having used drones since before the 2014 floods, they employs drones equipped with thermal cameras, gas detectors, and communication delivery capabilities, making drones an essential operational asset rather than a supplementary tool. All agencies agree that drones are highly feasible as a complementary technology rather than a replacement for traditional rescue methods. Drones are particularly effective for rapid area assessment, real-time monitoring, early detection of stranded victims, and the delivery of supplies such as medicines or communication equipment. Drones are effective in hazardous and low viability conditions, including night operations and flash floods, where human deployment would pose significant risks. Drones enhance situational awareness, reduce response time, lower operational risks, and improve coordination among rescue teams. However, several barriers to implementation remain. Technical limitations such as short battery life, low payload capacity, and strong dependence on weather conditions restrict drone usage to specific operational phases. Regulatory requirements from calm, high acquisition costs for advanced drones, and shortages of trained operators further hinder widespread adoption. Organizational readiness also varies, showing high preparedness through established SOPs and training. APM and PDRM require further investment and regulatory flexibility to fully integrate drone technology.